Today we are going to see polar plot in lecture 3 of control systems here. This is vanilla. So the open loop transfer function of a unity feedback is given by g of s is equal to 1 divided by 1 divided by s into 1 plus s into 1 plus 2s. Sketch the polar plot, obtain the phase and gain and phase margin. So step 1 is to check for the standard form. Standard form in the sense all the functions should be of 1 plus s, 1 plus 2s. So it should be of 1 plus. So it's already the form given here is in standard form. So replace, the second thing is to replace your s by j omega. So g of j omega equal to 1 divided by j omega into 1 plus j omega into 1 plus 2j omega. Step 2 is to find the magnitude and phase function. So to find the magnitude, so if it is going to be the complex, so modulus of your a plus ib, so is given by square root of real part plus square of imaginary part. So a square plus b square. So using this formula, we will be finding the magnitude. So modulus of 1 divided by square root of real part is 0. So 0 plus omega square into 1 plus omega square into square root of 1 plus 2 omega whole square is 4 omega square. So you have another rule, square root of a into square root of b is going to be square root of ab. So 1 plus omega square into 1 plus 4 omega square is 1 plus 5 omega square plus 4 omega power 4. And the square root of omega square is going to be your omega. So this is the magnitude function. And the phase function is given by tan inverse of b by a. For magnitude, a plus phase a plus ib can be obtained by tan inverse of b by a. So here the function is going to be three functions, 1 divided by j omega into 1 divided by 1 plus j omega, 1 divided by 1 plus 2 j omega. So 1 by j omega. So it's in the denominator. So minus tan inverse of omega by 0 will be infinite. So it's going to be 90 degree. 1 by 1 plus j omega. So it's going to be minus tan inverse of omega. And for this function, minus tan inverse of 2 omega. So fix the angular frequencies. So for that one, I'll be finding the corner frequencies. So corner frequency is real part by imaginary. So magnitude alone. So 1 by 1 will be 1, 1 by 2 will be 0.5. So the least one will be taking it in an ascending order. So this 0.5 I have taken it as first corner frequency and 1 as second corner frequency. So the tabular column is omega. So here first we have to get the first corner frequency and then the second corner frequency. We will be taking the least corner frequency. So with the condition less than that of your first corner frequency. So it can be 0.1, 0.2, whatever it may be, it can be. So I am just fixing it out, 0.35. In between 0.35 and 0.5, I have taken two values. In between 0.5 and 0.1, I have taken three values. So it's ideal to take minimum of 7 to 9 values so that we will be able to draw the graph neatly. So with the formula which we have formed for magnitude function, 1 divided by omega square root of 1 plus 5 omega square plus 4 omega power 4. So replace your omega as 0.5, 35, 0.4, 0.45, obtain the magnitude value. And here in this one, replace your omega as 0.35, 4, 4.5 and get the angle. So the next step is to plot the graph. So the first thing is here, this is the polar graph. You have to keep your 0 degree up. So here for each and everything you will be able to see 2 degrees here, right? So here in this polar graph, anti-clockwise will give you the positive angle, clockwise will give you the negative. So we will be dealing with the negative. So just plot it as minus, minus, minus. So the clockwise you get it as minus. So minus 10, minus 20, minus 30. Likewise, you just get the graph here. Then your magnitude value is going to be the range 2.2 to 0.3. So for this range, I will be taking 5 circles. I have 1, 2, 3, 4, 5. So I will be taking this 0.5, 1, 1.5, 2, 2.5. And then I will be drawing the graph here. So for omega equal to 3.5, your magnitude is going to be 2.4. And then here it is going to be 2.1, 2.2, 2.1 and 2.2. And then for this magnitude, I will be getting 144 degree. So this is going to be minus 140. So 141, 142, 143, 144. So here this is going to be your omega. So this is going to be your omega of 0.35. So 2.2 and then minus 144 degree. Then this is going to be 1.8 and then 150 degree, minus 150 degree for your omega 4.4. And for 0.45 the value is going to be 1.5 minus 156 degree. So for 0.5 it's going to be your 0.7, it's going to be your 1.3, and then here the angle is going to be your 160. Then this for every omega value you are going to plot the value, and then using the pencil you are going to join the dots. You are not supposed to use your scale, use your free hand to join the dots. So next step is to find the gain margin. So the rule to find the gain margin is the place at which the curve hits the minus 180 degree. So this is going to be the minus 180 degree. So where it hits the minus 180 degree, that magnitude I am supposed to take. From this origin to this one, the magnitude I have to take. So this is going to be 0.5. So this is 0.6 and then this is going to be 0.7. So your GA is going to be 0.7. So the gain margin is given by 1 by GA, which is equal to 1 by 0.7 is going to be 1.428. If you want gain margin in dBs, so you can use the formula 20 log 1 by GB, 1 by GA. So 20 log 1 by 0.7 is nothing but 3.10 dB. Next is to get your phase margin. So how to get your phase margin is, so unity circle. So you have to take your unity circle. So the point at which the curve hits the unity circle. So this is the point where the curve hits the unity circle. So that corresponding angle is said to be your phase, grain crossover phase. So this is going to be minus 180 degree. So phase margin formula is 180 degree plus gain crossover phase. So this gain crossover phase is going to be minus 168 degree. So 180 degree minus 168 degree equal to 12 degree. So gain margin is to find the distance between the origin and then the place at which the curve hits the minus 180 degree. And phase margin is, we have to see the curve at which phase it hits the unity circle. That is going to be your gain crossover phase, and you have to substitute in the formula phase margin equal to 180 plus gain crossover phase to get your phase margin. Thank you guys. Have a nice day.